This video is going to be part 2 of lesson 4. So in part 1 of lesson 4, we were calculating angle measures. In this part, we're going to be doing the exact same thing. We're going to be calculating angle measures, except we're going to be doing 2 class examples where we're dealing with radians instead of degrees. So we're going to do the exact same steps, but we're going to be in radians. Scroll down to class example 6. So again, how we could tell, so it looks like the exact same question, right? We actually did this question in part 1, but it said from 0 to 360. So this domain restriction here, this tells you that they want your calculator to be in radian mode. So you just have to be able to recognize and read that. So on your calculators, if you have the newer color calculators, it will tell you that you're in radian mode at the top, or you could select mode on your calculator and just make sure that radian is highlighted. You would hit enter and then you could quit. Okay, now that we're in radian mode, we are going to be doing the exact same things that we did in lesson 1 in order to find what the angles are. So the first thing we need to do is we need to apply the cast rule. And according to the cast rule, I need to find out or check off which quadrants is cosine negative. So I would say, okay, cosine is negative in quadrant 3, which is the tan quadrant, and in quadrant 2, which is the sine quadrant. So always find where our answer is going to lie, and my answer would lie in those 2 quadrants. From there, we need to find the reference angle. So in order to get the reference angle, what you would do is you would take the inverse cos of the absolute value of 0.5. So the inverse cos of 0.5 is equal to, and it's going to tell us up here like sort of how many decimals they want. It says the nearest hundredth of a radian. So I'll probably include a bit more decimals and then for the reference angle, and then I will clean up my answer at the end. So on our calculators, second function cos of the absolute value of 0.5 of negative 0.5 is just positive 0.5, and we get a reference angle in radians of 1.0471. So I'm going to write that down. 1.0471 dot dot dot, and remember that what we just calculated is our reference angle in radians. So now what we have to do, just like we did in part 1, is I have to put this reference angle in quadrant 2 and then in quadrant 3, and I need to calculate the rotational angle. So in quadrant 2, if I put a reference angle in this quadrant of 1 point, let's say 047, so that's the reference angle there. The triangle that is made is right here. They want the rotational angle. And now you just have to say to yourself, okay, we're working in radians. So this is pi. Pi minus the reference angle will give you the answer of the first rotational angle. So pi minus this answer here will give us a rotational angle to the nearest hundredth of 2.09 in radians, our answer would be. So I'm going to use theta, and the rotational angle is, again, 2.09 radians. And we don't need to write radians because we know that this answer is in radians. Okay, my second answer is going to be in quadrant 3. So I need to redraw this reference angle in the third quadrant. So draw yourself another Cartesian plane. And let's put a reference angle of 1.047 in quadrant 3. So that reference angle is 1.047. And here is my triangle. They want this rotational angle. So the rotational angle is going to be pi plus the reference angle will give me my rotational angle. So you could type that in on your calculator, pi plus 1.047, and what you will get is 4.19. And that's your second answer. Let's do the same thing for B, except there's going to be one thing that we have to pay attention to in B. Actually, 2 things. So first thing in B, we have the cotan of this angle here. And remember that we can't take the cotan. We don't have that button on our calculator. So we're going to type in the tangent because the reciprocal of cotan is tangent, or it's the reciprocal of the tan ratio. So tan of theta is equal to the reciprocal of this would be, what would that be? -4/5. Okay, I could find the angle by taking the inverse tan. So the inverse tan of the absolute value of -4/5 is just 4/5. And that's going to give me my reference angle. So let's see what that is in our calculator. So second function tan of 4 divided by 5 gives me a reference angle of 0.6747. So I'm just going to write for now 0.675 is what I'll write. So 0.675, that is my reference angle. Now what I should have done is I forgot, but let's do our cast. And let's find out where our answer will lie. C-A-S-T. So we're dealing with tan, and where is tan negative? Tan is negative in quadrant 4 and in quadrant 2. Something very important though. If we were to do this like the last question, I would have gotten 2 answers. But what I want to draw your attention to is the domain restriction. So they actually give us a domain restriction and they say, I want the answer to be less than pi, but greater than 0. So I want my rotational angle to be less than pi greater than 0. So what you have to say to yourself, okay, well, where are they talking about? Here's pi, here's 0. Less than pi would be in that direction. Greater than 0 would be here. So what that means is they only want us to give the answer in quadrant 2. We do not have to figure out the answer in quadrant 4 because you are outside of your domain restriction. And if this was a test question, you gave me an answer in quadrant 4, you would lose a mark for that. So let's figure out what our rotational angle is just in quadrant 2. So draw yourself a rotational angle, put in the reference angle, which was 0.675. Draw yourself your triangle, and then say to yourself, how do I get that rotational angle? It would be pi minus that reference angle would give you a rotational angle. And if you typed that in on your calculator, you would get 2.47 as an answer to the nearest hundredth. Okay, we've got one last class example to get through. But before we get through that, I want you to star something super important that you need to probably add to your study guide. So what we're going to do now is we're going to do the exact same thing, except we're going to give our answer in radians using like fractions. So I'll show you what I mean by that. So I just want you to sort of star this and we'll go through an example, okay? So the example that I want to quickly go through before we get to the class examples, I want you to type in the cos of theta is equal to -0.5. So if I said to you, okay, what is the cos of theta? You would say, okay, we've got to take the inverse cos of the absolute value of -0.5. So we would type in the inverse cos of 0.5 and clear your calculators. Let's put this in. So the inverse cos of the absolute value of 0.5 gives us a reference angle of 1.047. So 1.047, and that is equal to our reference angle. So what we're going to do is, if I said to you, how many radians is this on our unit circle? Like, give your answer according to an exact multiple of pi radians. So this is the wording that they would use. So give your answer as an exact multiple of pi radians. Here's how you would calculate that. You would take your reference angle. So what we're doing is step one. Divide the reference angle by pi and convert that answer to a fraction. So take this number, it's already stored on your calculator, divide that number by pi, and then simply convert that to a fraction. And what you would get is 1 pi over 3 radians. So theta r is equal to 1 pi over 3, or pi over 3 radians. That would be the reference angle written as an exact multiple of pi radians. Okay? So based on that, this is going to be question 5 in your homework. You're going to have to do this trick. So let's do this example, last class example. In each case, determine the exact values of pi within this domain here. So it tells us we want to be in radians. And the clue that they want us to do this is they use this word exact values, and that means no decimals. Okay, so the sign of 1/2. According to the cast rule, sign is positive in quadrants 1 and quadrant 2. So I'm going to have 2 different answers because both of those answers are within this domain here. So now let's find the reference angle. So to find the reference angle, we're going to take the inverse sine of 1 over 2, and that's going to give us a reference angle, and it's going to be an irrational number. It's going to be a decimal. So I'm going to do the second function sine of 1 over 2, and I'm going to get this number here. I want to know how many pi radians that is. So you take that number and you divide that by pi, and then you math one fraction this answer. And our answer is 1 pi, or pi over 6 radians. So pi over 6 is equal to my reference angle. So my reference angle is pi over 6. Okay, we need to find the rotational angle. So in quadrant 1, if this angle here is pi over 6, what's the rotational angle? And remember, in quadrant 1, the rotational angle is the same as the reference angle. So my first answer would be theta is equal to pi over 6. Then what I need to do is I need to draw a reference angle of pi over 6 in the second quadrant. So I'll do that over here. And if this is pi over 6, if that's my reference angle, what is this rotational angle here? So we know that this is pi, and it's going to be pi minus pi over 6. So let's get common denominators. Multiply both numerator and denominator by 6. And I will have 6 pi minus 1 pi. That's going to be 5 pi over 6. So this rotational angle is 5 pi over 6, and that's my second answer. Let's do class example B, and then I think I'll set you up with one homework question, and that will be the video. Class example B, the secant of negative root 2. So I know that I'm going to be doing reciprocals for this. So I'm going to put that over 1. So say to yourself, what is secant is the reciprocal ratio of what primary trig ratio? And that would be cos. So the cos of theta is equal to 1 over negative root 2, or we could say negative root 2 over 1. Doesn't really matter. I'm just going to move this over here. So the cos of theta is the reciprocal of this, which would be 1 over negative root 2. From there, let's figure out, according to our cast rule, where's cos negative. So according to CAST, cos is negative in quadrant 2 and in quadrant 3. So I've got two answers because they're both within the domain less than 2 pi greater than 0. From there, let's find the reference angle. So the reference angle is the inverse cos of the absolute value of 1 over root 2. So the inverse cos of the absolute value of 1 divided by the square root of 2. I get this reference angle here, and I need it expressed in terms of pi radians. So to do that, take your reference angle and divide it by pi, and convert that number to a fraction, which will be a quarter. So my reference angle is 1 pi over 4, or I'm just going to say pi over 4. Okay, you now need to take that reference angle and you need to put it into quadrant 2 and you need to put it into quadrant 3. So in quadrant 2, it would be right here. If this is pi over 4, so that little reference angle is pi over 4, I need to figure out what that rotational angle is, and I need to subtract pi over 4 from pi. So pi minus pi over 4, I'd get common denominators, and that's going to be 4 pi minus 1 pi is 3 pi over 4. So the first rotational angle is 3 pi over 4. So I'm going to say theta, because they use theta in the question, is equal to 3 pi over 4. Let's find our second answer, which is in quadrant 3. So in quadrant 3, I'm just going to have a clean Cartesian plane, and I'm going to erase this work, and we're going to find in quadrant 3, let's put our terminal arm. That has a reference angle of pi over 4. And this is going to be pi plus pi over 4. So the rotational angle is that pi plus pi over 4, which would give you 5 pi over 4 as your answer. So we have two answers for that, 3 pi over 4 and 5 pi over 4. So you can box that in. We don't need to do C yet. We'll do that one after we do lesson 5. Here is the rest of your homework. So we are going to do number 5, 6A. I want you to do 7 and 8, 10 and 11. And number 5, I've got that starred. So let's see why I have number 5 starred. Okay, number 5, the reason why this is starred is because it's got that word exact value. So again, if you wanted to just get like one quick review for number 5, let's do F together. So this is the secant theta of 2 over 1. Secant theta is the reciprocal of cos theta. And that's going to be 1 over 2. You would draw yourself your cast and you would say, okay, where is cos positive? And put check marks in those quadrants. So it's positive in its own quadrant and in quadrant 1. We then need to find, based on this, the what do we need to find? The reference angle. So in order to find the reference angle, you're going to type in the inverse cos of 1 over 2. And you're going to get probably a decimal, because oh yeah, and we need to be in radians. So the inverse cos of 1 divided by 2 gives me this. They said they want that word exact. So once you have that reference angle, you divide it by pi. And we get that. Then I go to math 1 fraction, and that guy is pi over 3. 1 pi over 3 is the same thing as pi over 3. So pi over 3 is my reference angle. In quadrant 1, if my reference angle is pi over 3, my rotational angle is pi over 3. So I've got the answer for quadrant 1. My next answer is in quadrant 4. In quadrant 4, if your reference angle is pi over 3, your rotational angle is going to be 2 pi minus pi over 3. Make yourself common denominators. So times this by 3 and times this by 3. This gives me 6 pi minus 1 pi is 5 pi over 3. And that would be your second answer. And that's how you would do number 5.